Dan Olds here on behalf of Hyperion Research and Inside HPC. We're going to have an interview with Steve Conway, who has had a storied career throughout HPC. How you doing today, Steve?
I'm doing fine, Dan. Thanks.
That's great to hear. So how did you get involved with HPC in the first place?
Well, first my work in college and in grad school was in literature, but I did work with computers a lot because I had a night job as a system operator for an IBM 360 machine in an insurance company. And then at a later job, I was a system administrator for a mini computer, a multi-user system. So I was always interested in computers.
And yet you were taking literature classes.
Yeah, everything was literature. I also kind of minored in physics, so I was kind of science too. But
that's unusual.
Then I had a consulting job where Cray Research became one of my very important clients. So I got involved with HPC there, and not too long after that, Cray hired me as head of communications for the company.
Ah, okay. What kind of consulting projects were you doing with Cray back in the day?
Oh, everything from surveys, employee surveys, to talking to all of their investors and financial analysts and industry analysts to just figure out how people saw the company, so that the company, which was really growing at that point very quickly, could figure out how to steer through all of its growth.
And doing probably quite a bit of education too, because computers and supercomputers weren't that well known back then, were they?
Education outward, but
that's what I mean.
I was being educated heavily inwardly by the folks at the company.
So what did you do after Cray?
Well, Cray got sold to SGI, and when that happened, because of the position I was in, I was dealing with investor relations also. A person in that job leaves. So I knew I had to leave. And I went into early internet companies as an exec with a company called CompuServe and AOL.
Oh, I remember. Yeah. I was a client of CompuServe's. Yes.
Okay. Yep. And then, and then Cray became independent within SGI for a while, then independent totally. So I worked for a bit for SGI in the Cray part of it. Then when Cray started up on its own in the year 2000, the CEO called me up and hired me to head up investor relations and communications, help get money for the company.
Okay. I remember those days. I was part of that transition from Cray to SGI, but I'm part of the piece that went to Sun.
Oh yeah. Well, I worked very heavily with all the folks in Beaverton at Super Servers, and so forth.
So how did you get into the sort of industry analyst game?
When Cray started up again, I had already had my own consulting company, so I was kind of operating as an analyst, and I told the new Cray that I would work there for 2 years, and I worked there to the day exactly for 2 years, and then got hired by IDC as an industry analyst. IDC kind of spun off Hyperion. IDC got sold itself to a foreign company. At
IDC and then of course at Hyperion, you guys really, how do I want to put this? But you've set the standard for what HPC market analysis and trend analysis should be.
Well, if there were a number of us, and some of us went on to other things. I mean, both Addison Snell and Chris Willard were colleagues, and really helped that business along also at IDC before they, as something happened where they went off on their own. So there are people who are no longer with us, but are doing a great job for the market.
But it's quite an organization and methodology that you've built there. And over your years, what are some of the biggest changes that you've seen in HPC?
Well, I think the first biggest change is the growth of the size of this market.
Yeah.
kind of in the supposed golden era when in the say the early 90s when the competitors were Cray, IBM, Fujitsu, Hitachi, NEC, the whole market with everything thrown in, hardware, software, servers, support, everything was worth about $2 billion worldwide. In
Wow.
2019, it was 28 billion, and we're forecasting it's going to go to 43 billion by 2024, not counting maybe another 7 or so billion in cloud usage. So this is like a 50 to 51 billion dollar market in a couple of years from a
It's
much.
incredible.
So that's one big change. Another big change is the systems themselves. They used to be these proprietary monoliths.
Yep.
They become much more modular, standards-based, heterogeneous, and that's allowed the market to democratize and expand. Without that, I don't think it would have. And it's also evolved from kind of a niche government-controlled market to a much more mature stage where it is a commercial market driven by commercial market forces. And for the vast majority of people, that's a good thing. Some
Yes.
legacy stuff always
Very
gets
much
left
so.
behind, but it's even for government. That's a much healthier thing. The other thing is the sizes of the systems have gotten so big, and the prices. It used to be that $30 million bought you the biggest supercomputer you could possibly buy.
Yeah.
And the new Fugaku system that's number one on the top 500 that just came out is $1 billion system, or it's $1 billion contract all told. So,
Well, and it's probably going to cost more than 30 million just to power the thing.
oh, yeah, I don't know what
Or
that
it's going
figure
to be a
is, but
big it's going to be a big number.
yeah, it's
It's
more
going
than
to
I
be.
can afford, or you
Yes.
probably.
Yes.
And I think the other big thing that's happening here is that finally, after lots of work by lots of people, governments around the world have recognized that HPC is not just for science, but it's crucial for economic competitiveness.
Yes.
And that recognition is what has allowed all these huge sums to be available for exascale systems. On the other hand, it's also led to there's kind of a disruption of the market, the indigenous uh, technology movements in China, Japan,
Mm-hmm.
Europe, because if it's so strategic, they don't want to be reliant on foreign forces or foreign
Yeah.
governments and foreign vendors. So there's this big push to develop indigenous supply chains and technologies. In the short term, that's disruptive. In the long term, if it goes right, then there ought to
It's
be
good.
more competition in the market.
Exactly. And you also look at, and I think you alluded to this, but HPC leaving the lab and going into the enterprise data center as well.
Oh yeah, that started very slowly about 10 years ago, and
Mm-hmm.
it's really picked up momentum. We tracked hundreds of companies that have adopted HPC for the first time, and there's an important distinction here. We're not talking about the automotive and
Yeah.
aerospace companies that are bringing HPC into HPC data centers for upstream R&D. This is live downstream business operations like sales and and HR and all
Retail.
that kind of stuff. And yeah, they're adopting HPC because enterprise server technology by itself can't do it anymore.
Yeah.
In these big global companies, HPC, the enterprise server technology stays there in the data center, but HPC gets integrated into it at very key decision points where very fast responses are needed.
Huge amounts of data, very quick execution time because they're making decisions off of it in real time almost. So
Yeah,
it's
and
extraordinarily important to have the performance.
yeah, we have lots of companies we talked with used to produce, reports from all their branches around the world once a month. Now they have to do it 5, 6 times a day.
Yeah, it's incredible.
Yeah.
You know what would be interesting that kind of spurred me from some of your earlier remarks is if somebody ever computed out what the cost to the customer per flop has done since, say, 1980 to
I
now.
think I think we at least used to do that. I don't know if we've done it exactly recently, but we have the ability to actually to do that easily.
Because even with $1 billion system, the cost of performance in that is per unit must be way down. I mean, it must be dropping exponentially over the
It,
years, I
it,
would think.
it is. I mean, this is, and part of that, of course, is the adoption of standard
Hmm.
technologies for a lot of what happens in HPC. So that reduces the price. It expands the market because you know, because everybody can use the stuff and the programming is the same. But now that's sort of changing because, as you know, the market is now becoming, in a good way, much more heterogeneous
Yeah.
with the technologies, but also the problems that it's tackling are becoming more heterogeneous. And you're seeing the architectures after a couple decades where things became increasingly compute intensive, but not so great for data. We're seeing the newer architectures come out that are designed to support data intensive work much more efficiently as well.
So that's a good springboard to our next question. Uh, where do you see HPC going in the next few years?
Well, it's already going there. I mean, we mentioned some of the areas. We mentioned that it's pushing into AI, or AI is pushing into it.
Hmm.
And I'd say enterprises pushing into HPC at the level of the large global corporations anyway. There's quantum computing. There's sort of the dance between on-premise and cloud computing that's happening. All of those boundaries are starting to melt down, and
Mm.
it's kind of like resistance is futile. You really don't want to resist what's inevitable, but there's always some of that. But the workflows that these systems have to handle, the spectrum of types of work is just growing enormously, and that's challenging from a system design standpoint, challenging from a programming
Oh,
standpoint,
yeah.
but that's where it's going, like it or not.
I also see I believe, more heterogeneity in systems with different kinds of accelerators, radically different kinds of accelerators in some cases, different designs. I mean, it was a big surprise to me to see that Fugaku was all CPUs,
Yeah.
no accelerators, but then to see, I don't know, I could probably show you a list of 50 or 60 companies, big and small, that are putting together their own accelerators.
Well, HPC is shifting to a workflow view,
Hmm.
which is more cloud-like. It's not the same as cloud microservices, but it's more cloud-like. And so uh, what we're seeing is um, architectures that are being designed to support, let's say, a workflow that might have to go on an on-premises workload, let's say, that might have to go through 20 different, very lightweight containers. Each one of them has to very quickly assemble different hardware, software, and even storage resources. And a workflow might go through 20 of these in a very short period of time.
Wow, that's
So
incredible.
think about, they have, as we have always said in HPC, or most of us, that uh, and I sort of mean this jokingly, but hardware is easy, software is hard, and so software continues to be the most challenged part of this.
Yes, yes. So, what has you, if anything, concerned about the future of HPC?
Um, Two things. One, that this indigenous movement around the world could get to be too nationalistic or regionalistic, and collaboration could suffer as a result. I don't think that will happen, but in the
Mm.
short term, I think there'll be some of that. The other part that's of course concerning, and particularly because I've been focusing a lot on AI, is what Stephen Hawking expressed very well, that this could go in two different ways. This could be
Yeah.
a very, very good thing, or it could be not very good thing. And so I'm concerned that the ethical side
Ethical
of
use of
AI
AI.
and all the rest of that will not be addressed sufficiently, that kind of the momentum of the market will overtake those considerations. That could be a problem.
That could be a very big problem. And it's hard to say how that problem starts, how that problem is stopped once it gets going.
Well, I think, there have been some good examples. Germany in 2016 came out with the first national law for governing automated vehicles
Mm,
and established some. I mean, they spent 2 years on that, and they had religious people and ethicists involved and all the rest of that stuff. So it came. Who knows how it'll work in practice? We don't have
yeah.
fully automated vehicles yet, but that's kind of the way to go. And I think China looked at what Germany did and said, that's a good model, and it's kind of headed in that direction. But we'll see.
Okay. Okay. So, final question. What has you most excited about HPC in the future?
Um, what always has had me the most excited, and it's not the systems, they're tools like hammers and nails. It's what happens when this gear gets into the hands of some of the world's brightest, most creative people, scientists, engineers, data analysts, and so forth. That's always the part that has excited me most, is not the systems. I mean, I'm paid to kind of understand them a bit, but really what people do with them.
And what comes out of that?
Yeah.
Fantastic. Well, thank you so much for the time, Steve. This has been a fascinating look at HPC and your roots and where you think things are going. Thank you.
Well, thank you, Dan. And I also want to give a big shout out to my friend and former colleague, Rich Bruckner.
Same here. Good job.